You are responsible for the development of an electric vehicle communication controller, and you're interested in a robust communication between the onboard charger and the charging station. Then I would like to show you now a very important feature of the D-Space smart charging solution. So welcome to another innovation coffee break about smart charging. My name is Florian Bauer. I'm project leader for the development of the D-Space smart charging solution. The smart charging solution provides two different modes. While the automatic mode is more used for plug and play, the manipulation mode can be utilized for error simulation. So you can test the robustness of your electric vehicle communication controller more in detail. What is now the setup? We have an electric vehicle on the one side and our charging station on the other side. There we have the smart charging interface, which is handling the communication according to the ISO and the DIN norm, for example. In the automatic mode, the vehicle, as the client, is always sending the V2G requests towards the charging station. The smart charging interface responds to those automatically and forwards all the communication directly to our real-time application. So you have access to all the information of the V2G communication, and you can access everything for having a real charging station emulation. In the manipulation mode, all messages are directly forwarded to the charging station and therefore the real-time application. So the response need to be answered out of the real-time application, and therefore you have full control over the whole charging process. So error simulation and manipulation, everything can happen in this mode. And that's exactly what I would like to present you in this session today. Now let's configure our charging station. We have a DC charging station with 500 volts. We now switch to manipulation mode. We will speak according to ISO or DIN. And then in the beginning, I would like to perform a test of the slack mechanism. So I go for the reported attenuation, for example, to 55 dB. And now we can plug in the plug. So now, as you can see, the pairing really worked. We went through the whole slack mechanism. And here you can see that we reported back to the vehicle all the carrier group numbers with 55 dB. So what else can we do now in the manipulation mode? We can, for example, change the timings. So here we've got all the different V2G messages already listed. And we can, for example, since we are now in the current demand phase, manipulate the current demand timings. So, for example, we go here to also 100 milliseconds, which is the performance timing between the request and the response. So I just activate that. Then I would go to the Wireshark, because there I can directly see what's happening. And if I go down here and have a look at the current demand response, and I see the difference between the last current demand request and the current demand response is 100 milliseconds. What else can we now manipulate? We can, for example, access directly the current demand responses. So as you can see here, the current demand is answered continuously. And here we have different signals, like, for example, the present voltage. This present voltage is actually measured within the charging station, and it's communicated within the current demand response. So the car is also measuring this, but we can here now manipulate. For example, we set it here to 360 volts. We switch to constant. And now we are communicating 360 volts back to the car, while the real voltage is different. But as you can see, we are still charging, and the car is fine with this manipulation. But now let's provoke a real charging stop. Therefore, I already prepared the charge parameter discovery response here on the right side. Typically, this is not sent here because we are now in the current demand phase and there are only current demand requests and responses. But with our smart charging solution, I can trigger responses which shouldn't happen right now. So therefore, I set here the response code maybe to failed. I switch to constant here, and as soon as I do a kick out, the car should stop the charging process because something is not happening correctly. So now I start the kick out. And as you can see, the car stopped the charging process. And since the car now stopped, we come to the end of the session today. Please keep in mind, we at DSpace have many solutions for e-mobility. So if you have any questions regarding charging or other topics regarding e-mobility, feel free to contact us. You're always welcome to discuss with us your applications. Thank you very much, and we see you soon.
DSpace, your partner in simulation and validation.